either given to us or the equation's going to be given to us so we can graph it. Oh, you can't see. I thought you were telling me I was being too loud and you were like, bring it down. Also that. Okay, here we go. Finding limits using graphs. I find that I'm louder after I drink my coffee, so I wasn't sure which one.
Kind of bad.
Huh? Is it? I feel like I'm extra loud right now.
You most definitely are.
No problem. I'll try to bring it down.
Oh, what? You're being
I don't know why, but I feel like the coffee makes me loud. All right. So we are going to be finding limits using graphs. So again, either the graph is going to be given to us, or the equation is going to be given to us, and we're going to be able to graph it fairly easily. We're going to talk about what are called left-hand and right-hand limits, and they're exactly what they sound like, either approaching from the left or approaching from the right. Remember, if you are looking for an overall limit, both of them have to match up. So what you're headed to from the left and the right have to be the same value. All right, let's look at the first one. This is a piecewise graph. Do you see how it says that the value is 0 when my t value, so that would be x in this case, based on where it's located, is less than 0. So notice it doesn't say less than or equal to. So here's what this is saying. I have an open circle at 0, and I'm going this way. So let's make sure we understand why that is. Remember, when it's equal to just a number, that's something horizontal. So I have a horizontal line at 0. It's starting at 0, but not equal to 0, and it's going smaller. So that's what this graph shows. Open circle shows me that I'm starting at 0, but it can't be equal to 0. So I'm starting like just to the side of it. So I'm starting at negative 0.00001, right? Like I'm not starting dead on 0, I'm starting just on the other side of it. And then all the way down through negative infinity. This other part is at 1. So I have a horizontal line at 1. It can include 0, so this would be a closed circle. And then it's a horizontal line to the right. So the first thing says, as t, or you can think of it as x, as t approaches 0 from the left, what does h of t approach? And so the way that we would write that is the limit as t approaches 0. Now, we have to say it's from the left. And when we're saying it's from the left, we're going to put a little negative up here. Because do you agree the further I go left on my graph, I'm going to get into negative land? Right? Negative numbers. So this is how it's written. The limit as t approaches 0 from the negative side. So that corresponds with this to the left business. Of h of t, and that's how this piece would be written in math notation. So that's me kind of translating the words. So let's find the answer to that just based off on the graph. We're not going to actually like graph it on our calculator and find the values like yesterday. So here's my graph. I'm approaching 0. Do we agree this is 0 in terms of x or t, whatever we want to call it? Okay, so I'm approaching this, and I'm approaching from the left. If I'm approaching from the left, what y value am I approaching? 0. So if I'm approaching from the left, again, I'm asking what y value am I approaching. As I head toward 0 in terms of x, what y value am I heading toward? Also 0. Bless you. So again, this is written out in words. This is written out in math talk. Okay? So be prepared to see it either way. The next one says, as t approaches 0 from the right, what number does h of t approach? So the way that we would write that is the limit as t approaches 0, but this time from the positive side. Right? Think about what's on your right. Big positive numbers are on the right side of your graph. Of h of t equals. Okay, so now we're walking along. We're headed toward 0 again. As I head toward 0, what am I heading toward though in terms of y? 1. So as I head that way, I head to 1. So again, I'm headed in towards 0 in terms of x. What's the y coordinate? The y value is 1. Since there's no single number the function approaches, we say if you're looking at don't write it like that. If you're looking at the limit as t approaches 0 of h of t, the limit does not exist. And oftentimes we don't want to write out long sentences, right? It's not English. So you can write DNE for does not exist, and that is also fine. So if you put equals and then you put DNE, I would know what you meant. So again, this is showing the left-hand limit. That does exist. I'm approaching 0. This is showing the right-hand limit. That does exist. It approaches 1. But the overall limit doesn't exist because they're headed toward different things. They have to be headed toward the same spot in order for the overall limit to exist. Let's look at another one. This one's already graphed for us. It's kind of a little bit harder to see, but not terrible. Okay, so here's my graph. We're not even given the equation, so you can kind of move beyond that. We've got a graph with an open circle. Remember, that means the graph doesn't exist there, but it exists everywhere to the left. We've got another open circle here, so apparently nothing exists at 1. And then it heads this way. We've got an open circle, but the point actually lives down here, and then we have the rest of the way. So that's what our graph looks like. Super interesting graph. And we're going to find some different limits. We're going to start with the weirdest spot. We're going to start with 1. So I want us to find the limit as x approaches 1 from the left, the limit as x approaches 1 from the right, and then we're going to look at the overall limit as x approaches 1. And we don't have an equation for g of x, so I'm just going to write g of x here. If you have the equation, you can write it in. We don't have that. Okay? So we're going to start there, and then we'll come back and deal with those other values in just a minute. If I approach 1 from the left, again, negative means left because that's where our negative numbers live. So as I approach 1 from the left, I'm headed toward 1. What's my y value headed toward? 5. Does it ever get there? No. Does the song help? Okay. Now we're headed from the positive way. I don't know. Anyway, we're headed toward 1 again from the right side, from the positive side. What are we headed toward in terms of y? 3. So these can exist. These left-hand, right-hand limits can exist, even if they're not headed toward the same thing. But overall, what would we say our limit is if it asks for the general limit? Are they going to the same spot? No. So the limit does not exist. So if we're looking at left-hand limit, it's 5. Right-hand limit is 3. Overall limit, not a thing. All right, here's the other interesting spot. Do you see my other interesting spot is 7? Okay. If I approach 7, again, you're approaching 7 in terms of x. So I'm headed towards 7. I'm walking along. Again, like kind of picture yourself, you're walking along the graph. I'm walking along the graph. What am I headed towards in terms of my y value as I walk along to 7? 4. Do we agree? Yeah. Okay, so I'm headed toward 4. Now, so this is me walking from the negative. This is me over here. Again, I'm going to walk on the graph. I'm headed this way now. I'm headed from the positive. If I'm headed over from the positive and I'm headed toward 7, what am I headed toward in terms of y? 4. Yeah, it should be 4. I don't know that it's perfectly level with 4, but we're going to pretend it is.
It's good enough.
It's good enough. We're going to call it 4. So, if I'm headed there from both directions, what's the overall limit at 7? 4. Where does my point actually live, though? 3. was just another kind of interesting situation. Okay? Flip when you're ready. We're going to do one more example. Yay, we're almost done. If you... Oh, I thought you were laughing at me. It's the okay. All right. I was like, what did I do that was super dumb this time? Okay. This looks awful. I'm going to rewrite it. And then we're going to do one more example. Okay, let's go f of x equals, and this is supposed to be written in a piecewise notation, but it's not. So x plus 8 if x is less than 3, and then 2x squared if x is greater than or equal to 3. I'm going to use two different colors for my graph. If you want to make your graph different colors, you can too. You do not have to. So I'm going to start with this piece, and I'm going to think about what my table would look like. We graphed these earlier in the year, these lovely piecewise functions. I'm going to start at 3, even though that's not truly a point this graph ever reaches or gets to. What's a number that would be smaller than 3 that I could add to my table? 2. And give me one more. 1. Perfect. Let's plug them in. So if I plug in 3, I'm going to get 11, and then I'm going to get 10, then I'm going to get 9. So those are going to be the points that I would like to graph. Next, let's find the other one, and then we'll actually get into graphing. Okay, so for this one, we're starting at 3, and we're going up. So we're thinking of numbers bigger than 3. You can pick any number if your numbers don't have to match mine. I'm going to start with 3. 3 squared is 9. 9 times 2? 18. So that's kind of large. That's fine. We can make that work. 4 squared is 16 times 2, 32. 5 squared, 25 times 2, 50. Okay, so since I'm going up so quickly, what I might do is, let's count by, I think I'm going to go 5. So I'm going to go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay, so I'm counting by 5 up to 50. Try to say that again. All right. Let's start with the green graph. For me, it's green. For you, it could be whatever color you chose. I've got 3, 11 as an ordered pair. What kind of point would I put there? Open, thank you. So 3, 11, so I'm going to go over 3. 1, 2, 3. So I'm still going to count by ones in terms of x. It's just the y's I'm counting by different values. 11 would be here-ish. And then I've got 2, 10. And then I've got 1, 9. And my graph is going to continue this way. That's what that piece of my graph is going to look like. Again, why we call it a piecewise function. Different pieces. Okay, next one. 3, 18. Open or close circle there. Close. Over 3. Up 18. Here-ish. Okay. And then I'm over at 4 and up at 32. So again, you graph it on your own, make it look good for your graph. I'm going to do my best up here to make mine fit. This should look like a parabola because, well, it is. It's quadratic. So I'm giving it a little bit of curvature. All right, so we have got 3 things that I want to find the limit of that are already here and ready to rock. I'm going to give you 3 more. D, E, and F. All right, here we go. I want to find the limit as x approaches 0 of f of x. The limit as x approaches 1 of f of x. And the limit as x approaches 4 of f of x. Okay, so those are the ones that I'd like to please calculate. Alright, let's start with 3. And 3 is kind of the interesting spot, isn't it? I mean, interesting is in the eye of the beholder, right? But I think it's interesting. So 3 is the interesting spot because that's where our graph works. So I'm approaching 3 from negative land. So again, here I am. I'm walking along my graph. I'm walking along my graph. I'm headed over to 3. What am I going to end up at in terms of my y? 11. So I'm headed toward 11. Now, oh, this is like dangerous to walk on the orange one. Oh my. I know, this is how I end up at urgent care. I like roll down the graph. Okay, so I'm gonna roll down the graph. I'm headed toward 3 again, dangerously, precariously. What am I headed toward in terms of y? 18. Am I headed toward the same thing? So the overall limit does not exist. So this is positive, or this is my right hand limit. So remember, these go together. Positive and right hand limit go together. So that's what this piece is right here. And then this was my left hand limit. So this is me coming from the negative direction, and again, my left hand limit. So this piece goes together and is this. Okay, so overall doesn't exist because we're headed toward 2 different things. Let's look at 0. So I'm headed toward 0 from either direction. So my person could be walking from either direction. If I'm headed toward 0, I'm headed toward my y-axis. What's my y value there? 8. Agreed. So again, think about your slope. If we had continued this, the next point would have been 0, 8. And we're headed that way no matter which way we're traversing that green line. Okay, now let's think about 1. If we're headed toward 1, here's 1. Again, we're on the green line. We're headed in from either direction. What are we headed toward in terms of y? 9. And then we're headed toward 4. Oh, I'm back on the dangerous one again. Okay, so I'm either really, oh, it's like the, what is it, Sleeping Bear Dunes when you have to hike back up and you get in trouble? That's what it is. So we're either hiking up or running down that spot at Sleeping Bear. Okay, so we're trying to get to this spot right here. What's it headed toward in terms of my y? So I'm headed toward this point right here. So again, I'm either coming down or I'm headed up toward it. What am I headed toward either way? 32. So think about like what's that y value that associates. So it's 32. So on the homework tonight, I'm going to tell you what the homework is, but then we're going to go over the chapter 9 test that we never went over. So the homework tonight, we're on assignment number 2. They're going to be similar to what we just did. Either the graphs are going to be given to you like on the front page, or we're going to have to create them ourselves like we just did. Page 846, 17 to 20, 29 through 32. So that's homework for tomorrow. Okay. You can go ahead and start getting stuff out and working on that.